this video, we'll be looking at the R and S configuration of chiral molecules. Determine the R or S configuration of the molecule below. To determine the R or S configuration of a chiral molecule, the first thing you need to do is to locate the chiral carbon. And the chiral carbon is the carbon with 4 different groups attached to it. This is a chiral carbon because it has 4 different atoms attached to it: bromine, chlorine, iodine, hydrogen. None of these groups attached to the carbon is repeating. This is not a chiral carbon because it has hydrogen repeating. So basically, a chiral carbon is a carbon with 4 different atoms attached to it. So once you indicate the chiral carbon or the chiral center, the next thing you want to do is to indicate priorities. The carbons, the number of atoms around the carbon, you number them according to their atomic number. The one with the highest atomic number takes 1, the next one takes 2, and the next one takes 3, and the last one takes 4. So let's give priorities to this chiral carbon. We have chlorine and bromine. Bromine has higher atomic number as compared to chlorine. So priority number one. Oxygen and chlorine and hydrogen. Which of them has highest atomic number? Well, chlorine has atomic number of 17. Oxygen has atomic number of 8. Hydrogen has atomic number of 1. Definitely chlorine is the second priority, and then oxygen is the third priority, followed by hydrogen, the last priority, which is priority number 4. The third thing you want to do is to look at your priority number 4. If your priority number 4 is on the dash wedge, then you have no problem. Aside it being on the dash wedge, then you got to do something to it. I mean, you have to do something to it. So now we count the priorities from 1 to 2 to 3 to 4. So we are counting to see whether it is clockwise, it's going clockwise or anti-clockwise. So from 1 we go to 2, 2 to 3, definitely you could see that it is going clockwise. If it is going clockwise, then it is the R configuration. So it is going clockwise. 1, 2, 3, right? So the trend is going clockwise. So this molecule has an R configuration. Our least priority, which is priority number 4, is on the dash wedges. So no problem. We have to leave it like that. So that is it for this problem. Write the R or indicate whether this molecule is an R or S molecule. So the first thing we want to do is to indicate the chiral carbon. Then after that, we start giving priorities according to atomic numbers. Among these 4 atoms around the carbon atom, iodine has the highest atomic number. So we give it to priority number 1. The remaining 3, which one has atomic number? I mean the highest atomic number. Bromine has an atomic number of 35, while fluorine has an atomic number of 9. So bromine followed by bromine. So priority number 2. Fluorine and hydrogen. Fluorine is definitely going to be priority number 3. And then hydrogen are least priority. Because we'll be meeting this term, our least priority group, let's call it LPJ, our least priority group, which is priority number 4. So anytime you hear LPG here, it means our least priority group. So now the next thing we want to do is to count the priorities, the indicated priorities from 1 to 2 to 3 to 4. So 1, where is 2 going? Are we seeing 2 here? No. 1 to 2 to 3. Yeah. So 1, 2, 3. So you could see that the trend of our priority is going clockwise, right? If you are to count anti-clockwise, you see 1, 3, 4 before you get to 2. And this is the closest. Priority after you start from 1 going to 2, looking for the nearest pathway to 2, to 3, and to 4. So this, since the trend is moving clockwise, then this is an R configuration, right? But before we indicate the group, we look at our least priority group. If it is on the dash wedge, then we have no problem. But if it is not on the dash wedge, we have to reverse the configuration. So this is an R group, but our least priority group is not on the dash wedge. So we have to reverse the configuration, which is an S. That is what you should do. So this molecule has an S configuration. So always you have to make sure that your least priority group is at the back of the chiral center. I mean on the dash wedges. If it's not on the dash wedges, then you have to reverse the configuration. So state whether this molecule is an R or S configuration. Well, this is our chiral carbon. We start indicating priorities by looking at the atoms around the chiral carbon according to their atomic numbers. So we have oxygen here. Oxygen has an atomic number 8. Hydrogen has an atomic number 1, making this place 9. Carbon has an atomic number 6. We have 2 carbons, making it 12. And 2 hydrogens here, 12, 13, 14. 3 hydrogens here, 15, 16, 17. So the total atomic number of this chain is 17. And this is 9. What about this? Carbon is 6. Atomic number of carbon is 6. Atomic number of hydrogen is 3. So we have 3 of them. So 6 plus 3, making it 9. Indicate whether this molecule is an S or R. Well, let's start indicating priorities. This is our chiral center with 4 different groups attached to it. Here we have a carbon here, and this is an ethyl group. We have a carbon here. This is a methyl group. We have an oxygen here. Definitely, oxygen has higher atomic number as compared to carbon. So oxygen should be number 1, and then our ethyl group should be number 2. This one has higher molecular weight as compared to this. So this should be number 3, and this should be number 4, our 4th priority. Now, what is the direction of our priority trend from 1 to 2 to 3 to 4? So 1, 2, 3, 4, then it is moving clockwise, right? If it is moving clockwise, it is an R configuration. If it is moving anti-clockwise, then it is an S configuration. So in this case, but we can conclude until we look at our LPG group, the least priority group. Is it on the dash wedges? Is it on the dash wedge or solid wedge? If it is on the dash wedge, we have no problem. If it is on the solid wedge, we have to change the configuration to the opposite direction. So our least priority group is on the solid wedge, not on the dash wedge. So we turn the configuration to S. So this is an S molecule. Is this molecule an R or S molecule? Now we indicate priorities. We have bromine, oxygen, and carbon here. Which of them has the highest atomic number? Bromine does. So bromine number 1. Now carbon, oxygen, and then hydrogen. Oxygen number 2, and then carbon number 3, and then hydrogen number 4. What is the direction of our priority flow? From 1 to 2 to 3 to 4. So 1, 2, 3, 4, clockwise. So an R configuration. Is our least priority group on the dash wedges? Number 4, is it on the dash wedges? Yes, it's on a dash wedge. So this is an R molecule. So now indicate whether this molecule is an R or S molecule. Now, this is kind of a bigger molecule as compared to this. So what we do is to locate our chiral center. Our chiral center is a carbon with 4 different groups attached to it. Here we have a carbon atom here, carbon atom here. They cannot be chiral because there are hidden 3 hydrogens here, and there are hidden 2 hydrogens here, right? So this cannot be chiral, this cannot be chiral. But this carbon atom here can be chiral. What about this carbon? Remember, if we have a carbonyl group, in the presence of a carbonyl group, there will be a total of, because of the double bond, we are not going to get separate separate group attached to the carbon. So anytime you see a carbonyl group, generally know that it cannot be a chiral carbon. So if you see a carbon bonded to double bonded to oxygen, it cannot be a chiral generally. Cannot be a chiral carbon. So now our focus is on this carbon. So now we are going to indicate priorities. We have carbon, hydrogen, and bromine, and we have an ethyl group here, and we have a carbonyl group here with an hydroxyl group attached to it. Shall we call it carboxylic acid group? So now let's indicate priorities. If we sum up the atomic numbers of carbon is 6, hydrogen 2, making it 7, 8, bromine is 35. We are going to get 43 in all, 43 atomic weight. Atomic weight. And for this one, oxygen plus oxygen, 6 plus 6, 8 plus 8, giving us 16, plus 1, hydrogen has an atomic number of 1, making it 17, and plus carbon, which is 6, will give us 23. So 23 weight. And here we have an ethyl group, carbon here, 6, 2 hydrogen, 7, 8, 8. And here we have carbon here, 6, 3 hydrogen, 7, 8, 9. So 9 plus 8, giving us 17. So now 43, 23, 17, and the hydrogen here 1. Definitely this right here should be our priority number 1, followed by this priority number 2, followed by this priority number 3, followed by hydrogen priority number 4, because this has high atomic weight as compared to that and that. So now let's look at the flow of our priority trend from 1 to 2 to 3. So 1, 2, 3. So this is how the flow goes. 1, 2, 3. So now it's going anti-clockwise. Since it's going counterclockwise, it is an S configuration. But let's look at our least priority group. Is our LPG on the dash wedges? No, our LPG, which is priority number 4, is on the solid wedge. So we turn the configuration. So this becomes an R molecule. So the configuration of this molecule is R. Indicate whether this molecule is an R or S. Now this is a chiral carbon. Since we have a carbonate carbon here, that one cannot be chiral generally. So this is a chiral carbon. It has oxygen and hydrogen attached to it, and definitely oxygen and hydrogen is going to will be the priority number 1. Now oxygen is definitely going to be priority number 2 here, and we have a carbon atom here, which is going to be priority number 3, and then the hydrogen to be priority number 4. You might be wondering whether this carbon atom here is chiral or achiral. The carbon atom is chiral because there's no line of symmetry that will divide this into 2, so that we have two carbons at the right, 2 carbons at the left. If we divide it this way, we are going to get 2 carbons here, but we will get 3 carbons at that side. If we divide it here, we are going to get 2 carbons here and 3 carbons at that side. Not that just carbons, but this side we also have a carbon double bonded to oxygen. So this carbon atom is chiral. So now, what is the trend of our priority from 1 to 2 to 3? 1, 2, it doesn't matter, since 1, 2 is closer to 1 here, we are going anti-clockwise. So 1, 2, 3. So now it is counterclockwise. But it's a least priority group on the dash wedges. This should be dash wedges. On the dash wedges, yes, our LPG is on the dash wedges, so no problem. And since the priority trend is going counterclockwise, this is an S molecule. Indicate whether this molecule is an L or S molecule. Now we'll be looking at the chiral centers. How many chiral centers do we have in this molecule? Well, let's start let's start analyzing. We are looking for the carbon atom with 4 different groups attached to it. Let's look at this carbon. It has bromine OH and it has carbon here. If you come here, it has carbon here. Let's go further to see. Second one, we have carbon here. Second one here, we have a carbon here with an isopropyl group. So this side of the molecule is different from that side of the molecule. So this carbon is chiral. So let's start indicating priorities. Bromine has the highest atomic number, so priority number 1, followed by OH, oxygen will follow to oxygen. You can just focus on the first atoms. And now, in this case, when it comes to carbon and carbon, we continue tracing to see which one will have a substituent. So we trace one here, we trace one here. There's no substituent, so let's trace 2. Trace 2. This one has a substituent. So the one with the substituent will definitely have higher priority as compared to the carbon without substituent. This carbon right here has an isopropyl group, so it should have higher priority as compared to this carbon here, which has no substituent. So this side of the chain will be our priority number 3, and definitely this side will be our priority number 4. And now let's see the trend of the priority from 1, 2, 3. So it's going clockwise, right? It's an R configuration, right? But we have to check our least priority group. Is it on the dash wedges? This is our least priority group. It is not on the dash wedges. So definitely we have to turn the configuration. So this chiral carbon here has an S configuration. Determine the absolute configuration of this molecule. Of these molecules. Let me draw it before. You have to determine the absolute configuration of these 2 molecules. Let's start with this. This carbon has the probability of being chiral. For the rest of the carbons, they cannot be chiral because this one, they have 3 hydrogens attached to it here. This one, 2 hydrogens. This one here, 3 hydrogens. So let's say our focus should be on this. So bromine should have the priority number 1, and now hydrogen, carbon, methyl group here, and then an ethyl group. So the carbons definitely have higher atomic number as compared to hydrogen. So this is a methyl group, so it should be our priority number 3. Sorry, this is an ethyl group, so it should be our priority number 2. And this is a methyl group, so it should be our priority number 3. And hydrogen should be the last one. So now, what is the flow of our priority indication? Is it clockwise or anti-clockwise? Priority indication will move from 1 to 2 to 3 to 4. In this case, if we move to the right, we have to jump 1 priority to get to 2. If we move to the left, anti-clockwise, we also have to jump 1 priority to get to 2. So in this case, we choose to take the right path, to move clockwise. So indication is going to the right. So this should be an R configuration since it's going to the right, but it's a least priority group on the dash wedges. Where is our least priority group? Here it is, number 4. It is on the solid wedge, so we have to change the configuration. So because this is an R and our least priority group is not on the dash wedges, we turn the configuration. So this is an S configuration. So we have to determine the absolute configuration of this molecule. So it means we have to give the name of the molecule. This molecule has 4 carbons. So it is a butane. And it has no double bond, so butane. So it has substituents here, bromine. So let's start numbering, taking the closest pathway to get to the substituent. So 1, 2, 3, 4. So now the spatial nomenclature will be in bracket followed by the other name. So At 2, the carbon is chiral at number 2. The carbon number, at number 2 is chiral. So we have, and the configuration is S. So we have 2S, 2S, and at carbon number 2, we have bromine there, dash 2 dash bromobutene. That should be the name of this molecule. But you can decide to just call it S2 bromobutene because we have only one chiral center. No problem with that. If we have more than one chiral centers, we have to indicate the number of the carbons which are chiral. For this molecule, this carbon cannot be chiral, this cannot be chiral, this can be chiral, this can be chiral, this cannot be chiral. So let's look at this carbon right here. We have bromine and then hydrogen. This carbon looks like symmetrical, but it's not symmetrical because if we divide this carbon into 2, we are going to have carbon here with substituent and the rest they won't have substituent, so it's not symmetrical. So looking at this carbon, our bromine here should be priority number 1, and we have carbon, which will have higher priority than hydrogen. So we trace one carbon, This carbon has substituent, so it's going to be our priority number 2. This because this carbon does not, it has only a metal group attached to it. This one has chlorine and hydrogen, so it's definitely going to have higher priority than metal group here. So this should be our 3rd priority, and this should be our 4th priority. What is the flow of our priority? 1, 2, 3, 4. So it definitely going clockwise. So it's our least priority group. If it is clockwise, then this carbon is an R, right? But what happened to our least priority group? Is our least priority group on the dash wedges? No. So we have to turn the configuration. So this carbon here is going to be an S. Let's look at this carbon here. We have chlorine, definitely priority number 1. Hydrogen, carbon. This carbon should be priority number 2 because it has a longer chain. Priority number 2. And this will be priority number 3. And this will be priority number 4. So for this one, we choose to move to the right. So 1, 4, 2, 1, 3, 2. So in this case, we choose to move to the right. This giving us an R configuration. Now that we are done indicating the configuration of the chiral atoms, we now go to the naming. So naming it, this is an alkane. So this should be the shortest way to the substituents. So 1, carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. And it is a pentene, right? So at carbon number 2, first of all, the special nomenclature should come first. At carbon number 2, which is chiral, the configuration is R, right? So 2R, then comma. At carbon number 3, the configuration is S. So 3S, bracket close, because we have 2 chiral centers. No matter the number of chiral centers you have, you have to bring them in. If it is 4, you bring it right, comma, out to the last chiral center that you have. So now you bring in a dash, start naming the molecule. At carbon number 3, we have bromine. Carbon number 2, we have chlorine. B comes first before C. So we are going to have 3 dash bromo. Then after that, bring dash, carbon number 2, we have 2 dash chloro. We are done with all the substituents attached to it. For hydrogens, we don't count them. Chloro, and this is a pentene. Determine the absolute configuration of these Fischer molecules. the molecule has been drawn in facial projection form. You have to determine the absolute configuration of this molecule. Now we start looking at the chiral carbons. The carbons in the middle, carbons with 4 different groups attached to them. This carbon is chiral. It has OH group, CH group, hydrogen, and then the methyl group with other substituents. Ethyl group with other substituents. The same happened to this carbon. So let's determine the configuration of each chiral carbon. So now we are now to stand on this carbon. It has oxygen. Oxygen will definitely have priority number 1. And it has carbon here, methyl group and an ethyl group. Ethyl group will definitely have higher priority than this, the priority number 2, and the carbon priority number 3, hydrogen priority number 4. So how is it moving? We have 1, 2 in that order. So it's definitely going clockwise, right? But one thing you need to know about facial projection is that this is the structure of facial projection. Something you need to know. Those molecules from the up and bottom part are on the dash wedges. Like this molecule, this group here is on the dash wedge, and the other group here is on the dash wedge if we are taking this carbon into consideration. And those are the sideways are on the solid wedges. So if our least priority group is not either at the top or the bottom, then we have to change the configuration. Remember, our least LPG, our LPG should be on the dash wedges. So here, LPG number 4 is on the solid wedges because it's kind of on the sideways. So comparing to this, it's on the solid wedge. So we have to turn the configuration. This is R, but we have to turn the configuration to get an S. So let's look at this carbon here. Let's indicate priorities. Bromine, we have priority number 1. Methyl and then ethyl group. Ethyl will have priority number 2. And then methyl will have priority number 3. Hydrogen will have priority number 4. So now let's see. How is it going? 1, 2, in that order. So in this case, it's moving counterclockwise, which is S configuration. By hydrogen, our least priority group is on the sideway. So it is not on the dash wedges. If you compare to this, it's not at the bottom or at the top. So we have to change the configuration to get an R. So we want to give the absolute configuration of this molecule. This molecule is an alcohol, right? You could see that it has an alkyl alcohol. It has an OH group, and then for the alkyl, they are just substituents. The halide, they are just substituents. So this molecule is an alcohol. And how many carbon atoms does it have? Let's see the longest carbon chain. So 1, 2, 3, 4. So it is a butanol. So 1, 2, 3, 4, which is but. We have to name the special part first. Now, numbering the carbon atom really matters. We first have the one closest to the functional group and then to the bromine, right? The substituent. So we have to number from top to bottom, then numbering from bottom to, because if we have to number here, we'll get to the substituent before the functional group. So this is our chiral carbon number 2, and its configuration is an S. Sorry. So 2S, that should be in bracket, comma. And at chiral number 3, the configuration is R, 3R into bracket, bring in a dash. Where do we have the substituent? At carbon number 3. So we are going to have 3 is a bromo. 3 bromo dash. Let's indicate where our functional group is. Which carbon is our functional group on? Carbon number 2. 2 butanol, right? Butanol. So that is it for this problem. give the absolute configuration of this Fisher projection. So now, I think you could see three chiral centers, which is this and that. So now let's focus on this for now. We have a bromine, which will give us priority number 1, and then metal, and then an ethyl with other substituent, which will be priority number 2, and here will be priority number 3, and this will be priority number 4. How is the sorry? So how is the direction moving? So from 1 to 2 to 3 to 4. So it's moving this way, right? It's moving this way. So S, right? But our least priority group is not at the top or at the bottom. Since it is at this side means it is on the solid wedge. So we have to change the configuration. So this is going to be an R. For this chiral center, it's going to be an R. So let's look at this chiral center. So we have chlorine is going to be priority number 1. Then we have an ethyl group here. We have an ethyl group here with a halide, which is definitely going to be our priority number 2 because of the halide. And here will be the priority number 3, and this will be priority number 4, the least priority group. So now, how is the direction moving? So 1, 2, so it's moving this way, which is an R. But is our least priority group at the top or at the bottom? No, which means it is on the solid wedge, so we have to change the configuration. So this is going to be an S. So now, this molecule is just an alkene with substituent. It has no functional group. So let's name it. Where is the longest carbon chain? We have 1. Let me use black pen. 1, 2, 3, 4. So what's the special name for this chiral carbon? 2R, right? We have 2R. What about this chiral carbon? This carbon is 3. So 3S. 3S. So now the name is going to be 2R, 3S into bracket dash. On carbon number 2, we have a bromine there. 2 dash bromo. On carbon number 3, we have a chlorine there. Dash 3 dash chloro. And this carbon is 1, 2, 3. 1, 2, 3, 4, 5, right? Which is pentene, chloropentene. That is it for this video. Feel free to check my videos on stereochemistry, how to use the molecular orbital diagram to predict reactions. Just search for Frontier Molecular Orbital Diagram at LIB Academy. Search for that. It will help you to handle pericyclic reactions and a lot of stuff under stereochemistry. Generally, you can check my videos on that. My playlist on stereochemistry, chirality, optical activity calculations, and many more. That is it for this video. See you in my next video. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.